So let us have this simple example of operation of DKIM. Uh, we began with a message generated by a user and transmitted into HMS to an MSC within the user's administrative domain. An email message is generated by the client program. The content of the message plus selected RFC 5322 header is signed by the email provider using the provider's private key. The signer is associated with a domain which could be corporate local network, and an ISP is or a public email facility such as a Gmail. The signed message has passed through an internet via a sequence of MTAs. At the destination end, this MDA retrieves the public key for the incoming signature and verifies the signature before passing the message on to the destination email client. The default signing algorithm is RSA with SHA 256 or RSA with SHA 1 also may be used over here. So let's see how actually the things are going to get presented over there. So this diagram example consisting of an DNS and mail delivery agent, a submission agent, transfer agent, and user agent. With the help of this, the client can send a mail from one end to another end. Such a way the DKIM is going to be get deployed in this particular sequence. Let's discuss in detail about the DKIM functional flow. This figure illustrates a more detailed look at the element of DKIM operation. Basic message processing is divided between a signing administrative management domain and a verifying administrative management domain. At its simplest, it is between the originating ADMD and the delivering ADMD, but it can involve other ADMDs in the handling path. Signing is performed by an auth module within the signing ADMD and uses private information from a key store for the signing within the originating ADMD. This might be performed by the MUA, MSA, or an MTA. Verifying is performed by an authorized module within the verifying ADMD within an delivering ADMD. Verifying might be performed by an MTA, MDA, or MUA. Then the module verifies the signature or determines whether a particular signature was required. This verifying signature uses the public information from the public key store. If the signature passes, then it's going to be get processed into the next level, which is a reputation information is used to access the signer, and the information is passed to the message filtering system. If the signature is failed, or there is no signature using the author domain, information about signing practices related to the author can be retrieved remotely and or locally, and the information is passed to the message filtering system. For example, if the sender uses DKIM but no DKIM signature is present, then the message can be considered fraudulent. This signature is inserted into the RFC 5322 message as an additional header entry, starting with the key word as DKIM signature. An example, we can have an incoming mail by using the view long header. It's an optional for an incoming message. So before a message is signed, a process known as canonicalization is performed on both the header and body of the RFC 5322 message. Canonicalization is necessary to deal with the possibility of minor changes in the message made en route, including character encoding, treatment of trailing, white space in the message lines, and the folding and unfolding of the header lines. The intent of canonicalization is to make a minimal transformation of the message. For the purpose of signing, the message itself is not changed. So the canonicalization must be performed again by the verifier. That will give it is best change of producing the same canonical value at the receiving end. DKIM defines two header canonicalization algorithm, simple and relaxed, and two for the body with the same names. The simple algorithm tolerates almost no modification, while the relaxed tolerance common modification. So let's see about the signature, which includes a number of fields. So it's nothing but V DKIM version A, an algorithm used to generate the signature must be either an RSA SH1 or RSA SHA256. C, canonicalization method used on the header and the body. D, a domain name used as identifier to refer to the identity of a person or a responsible person or organization. In this DKIM, this identifier is called a signing domain identifier, SDID. Next one, yes, in order that the different keys may be used in different circumferences of the same signing domain. DKIM defines a selector which is used by the verifier to retrieve the proper key during the signature verification. Next one, signed header field H. A colon separated list of header files names that identify the header file presents to the signing algorithm. Then BH, the hash of the canonicalized body path of the message. This provides an additional information for diagnosing signature verification failure. The last one, B, the signature data in the base 64 format, radix 64 format. This is the encrypted hash code. So hope that we have come to the end of this DKIM, domain key identified mails. And we have come across with an internet mail architecture and email threats, and we have discussed about the characteristics, capabilities, and the location of the email threat in the particular domain key identified mails, and we have discussed about the strategy and the functional flow of domain key identified mails. Hope that this video may be helpful for you people to understand about the domain key identified mails in the email architecture. So if you have any queries, kindly you can post the queries to me. So thank you for watching my video. Thank you.